Good morning, everyone. This is lesson 2 from chapter 4 from the geometry, triangle congruence by SSS and SAS. Before we start our lesson, we need to warm up by looking at this figure. This figure is showing two triangles. The triangles, they look congruent to each other, but as we said in geometry, we cannot just say they look congruent. We have to prove the congruence by using the congruence statements that we've learned in the previous lesson, which is 4.1. Okay? Now, as we agreed in the last period, that if it's a triangle, if the figure is a triangle, we need to have 6 congruence statements, 3 related to the sides and the 3 related to the triangles. If we have a close look at the figures here, we have the first side pair, this side, is congruent with which side? Yes, JK. And the other pair is GH is congruent with what? KL. Yes. And the third pair is JL is congruent with FH. And as I said before, it's okay if I say FH or HF, the way you want. In the order, in the pair itself, in the line segment itself, it doesn't matter. Now we finished the sides. We'll compare the angles. If I look at the first angles pair, angle F congruent to angle J. Yes? Angle K is congruent to angle G. And angle L is congruent to angle H. In this way, I wrote the 6 congruent statements, 3 related to the side and 3 related to the angles. So I can easily write the names of the congruent triangles. And as I said to you in the previous period, that the name should show the congruence. How? You can just take one side from any triangle. Let's say, for example, FG, and I will write the congruence symbol. And then, what is congruent with FG in the other triangle? JK. Now, I need one letter to finish the triangle. So FGH, I will put the last letter only, and JKL. In this way, I wrote the correct name for the two congruent triangles. Now, the objective of this lesson is to prove the congruence between the two triangles in two different postulates, which are SSS and SAS. The SSS is related to the side, and SAS is as a side angle side. Now, the teacher, you told us from before that we should write the 3 side pairs and the 3 angles pairs, but this is too much, and not in every single question you will have all the symbols on each figure. We will know today that we can have enough by having the 3 sides pairs, or we'll talk about it later. So we'll start by the side postulate. What does it mean? The theorem or the postulate is telling you if you were able to find the 3 sides pairs, this means your triangle is congruent. If you have the 3 sides pairs, this means the triangles are congruent. We'll start by the first side, BA with congruent with what? DE. EF congruent with what? BC. And the last one, AC congruent with DF. If I was able to find this in my question, this means my triangles are congruent. Now let's start our lesson. The lesson here by how to prove using the SSS postulate that those two triangles are congruent. As usual, we will look at the related or the corresponding sides, and I'll try to highlight them so it will be easy for you to track my work. when I say the question is saying LM congruent to NP, so LM is congruent to NB. This is the first side. I need two more sides. The second one is LP is congruent to NM. This side is congruent to this side. Okay, did he give me something else? No, but he gave me what? That the third one is common between the two triangles. It is drawn in the first triangle and the second triangle because these are two connected triangles with each other. And what was the name of the property that we were saying if we have such case? This is called reflexive property. So if I have two sides pairs given and one of them I can find it in the reflexive property, so I can say that my two triangles are congruent. Let's say got it to check our understanding. First, if I look at the figure, he gave me CB or BC as written in the question is congruent to BF. We'll write the reason after. This is the first side pair. The second one, I will say that if D is congruent to CD, this is the second side pair. I need the third one. Did he give me something else? No. So what do I say? BD is common, right? So I can say BD is congruent to BD. And here, what's the reason? I write reflexive. Okay? The first two reasons were given. And for the first and the second, given. So what's the rule? What's the result? That my two triangles are congruent. That's it. Let's go to the second postulate. As we explained SSS to be side, 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 we are explaining the second one to be side, side. Let's highlight the second one. Okay, side, and then side, and an angle in the middle of them. Side, angle, side. This means I have two line segments connected with one vertex. This vertex, I have an angle formed in here. If I have this combination between the sides and the angle in two triangles, this means I have achieved the SAS, which is the side angle side. In a condition, not any angle given in the triangle will make the postulate correct. It should be, as I highlighted here between the two blue lines, this angle to be given in the two triangles pair. Let's see how the question will come. As I said before we solve the question, here another explanation for the theorem. If AB is congruent to DE and AC is congruent to DF, and he gave me that this angle is congruent to this angle, this means my both triangles are congruent. Let's see. He's telling me in problem number 2, what other information do you need to prove that the triangle DEF is congruent to the triangle FGD by SAS? So he doesn't want SSS, he wants SAS. So my job is to find two pairs of sides and an angle included between them. Let's start highlighting our sides. He gave me that EF is congruent to DG. Okay, this is the first side. Did he give me something else? No, but I know that this side is common. Sorry, I'll use another color. This side is included in both triangles. Okay, so what angle I need to achieve the postulate or to prove the congruence through this postulate? The angle which is in between them. So this angle between my both lines, blue and green, and this angle between my both lines, blue and the green. So what's the name of the first one? It's EFD, and the second one GDF. So to prove such a question, he should give me this pair of angles to be congruent, to be able to say that my triangles are congruent using SAS. Let's look at the got it. He's saying to me, look at the figure. Through this figure, what is the missing information that you need to prove that LEP is congruent to BNL? I will look at this. He gave me an angle. So the first angle is this. Is congruent to this, okay? Did he give me sides? No, but this is a common side. Okay, so what do you think I need? I have a side, an angle. I need one pair of sides to be congruent. Which side is this? Is it LN and EB or LE and NB? It is LE and NB. LE and NB. Those should be congruent. So he should tell me that LE is congruent to NB. Should be given. Let's move to the problem number 3, to identify the congruent triangles. I will say, he said, would you use SSS or SAS to prove the triangles congruent? If there is not enough information to prove the triangles congruence, write not enough information, explain your answer. We'll solve the first one, and we will highlight the congruent side. This side is congruent with this side. This is the first side. This side is congruent with this side. I have two sides. Do I have any mark on the third side? No. Do I have any given angles? Yes. So the angles are between the two sides? Yes. This angle is congruent with this angle. So I can say use SAS because two pairs of corresponding sides and their included angles are congruent. We'll solve B as well. Here we will highlight. He didn't give me the three sides, he gave me the two sides and angle. My job is to make sure that the angle is in the middle between them. This side with this side, and this side with this side. Here the angle is in the middle of the side. Does it have the same with the other side? Is this angle given? No. So you say there's not enough information. The two pairs of corresponding side are congruent, but one of the angle is not the included angle. Okay, let's go and solve. Let's go and solve the got it. Would you use SSS or SAS to prove the triangles at the right congruent? As shown in here, that I'm given the three pairs of sides. He gave me the three sides, okay, and I need just to make sure of if the angles can be given. I'll say, this side is congruent to this side. This side with the two dashes is congruent to this side, and the last one, this side is congruent to the side. So I was able to prove that they are SSS congruence. Okay, let's see if the angle that it's given between the yellow and the blue. Here it's given in the first triangle or triangle number 1. It's given between the yellow and the blue lines. And the angle is given. Is the other angle given between the yellow and the blue? No. So we can say that because the given angle in triangle number 2 is not included between the sides. Okay, now let's go to the lesson check. We'll solve A. He's telling me in the triangle PEN, so let's draw the triangle PEN. Every time you need to solve a question, just try to sketch it to imagine what he's telling. He said the side PE. This is the side PE. And the side EN. Where's the angle which is included between them? Yes, what is it? What is it? This angle. What do we call it? Angle A. Okay. Let's see. Question number 3. Question number 3. He's telling me name the postulate. When he says to you name the postulate, this means which is postulate you will use, SSS or the SAS. Okay, now I just want to show it to you here to zoom. Yes, now if I have this in here, the first side congruent to the side, the second side congruent to the side. He didn't give me the third side, but I can tell that there is an angle in here congruent because it is vertical, right? So which theorem we will use or postulate we will use? SAS. Let's go in here. Question number 6, error analysis. Your friend thinks that the triangles shown below are congruent by SAS. Is your friend correct? Explain. Let's see. Our job to make sure that the angle given is between the two sides. Here's my side. Here is the triangle, the other triangle side. We need to make sure the angle in here is not given between them. So, is your friend correct? No, because angle is not included. No, because the angle is not included. Now, we'll solve question. I'll solve it with you. Question 8 to finish this lesson. Here we have those two triangles which are JKM and LMK. Okay, now he's asking me to prove them. He gave me that JK is congruent with LM, and he gave me that KL is congruent with JM, and I found out that this is congruent. So if you say that JK is congruent to LM, this is given. JM is congruent to LK. JM is congruent to LK as well. This is given. The third one, K is congruent to KM. This is what? This means that we are using the reflexive property. Okay, so which triangle is congruent to which triangle? JK with LM and KM with MK. So the triangle JKM is congruent to LMK. And these are the pages of your homework. The number of the question that you need to use are written in the weekly plan. I hope you understood every part of it. In this lesson, we've learned what's the meaning of SSS and SAS. Those the two postulates that you can use to prove the congruence of the triangles. As I told you, if you prove the 6 congruent statement, this will be more than enough. What we need is at least the 3 sides or the side angle side in a condition that this angle is common or included between them all.